want to make sure that I point that out to you. Okay, thank you. Okay, so what am I going to do? Is that a 7? Yes. Okay, so I'm going to factor. Do I have a perfect square trinomial?
Yes.
I do have a perfect square trinomial. I love those. And so what do I need to do for my least common denominator?
Multiply by 7.
On the left, I have to add multiply by 7. And on the right, I have to multiply by q plus 1. Okay? So I am multiplying by 7 over 7. And on this side, it is going to be q plus 1. Okay? All right. Now, is everybody okay with that so far? So now I am going to multiply it out, and 7 times 4 is 28. And q, now I highly recommend that you use parentheses here, because you are multiplying a monomial by a binomial. But, and I know that you guys can do that in your head without a problem. The problem is this thing. So if you remember that this is in parentheses, so I have q times q is q squared, q times 1 is q, no big deal. But it is minus this quantity. What is that going to do to everything inside? It's going to change everything. And so I am going to have, okay, I have 28, sorry. Just want to stay there.
Could you just do 28 minus parentheses a squared plus q?
That's q squared. What do you want to do?
Which means instead of doing 28 minus q squared minus q, just do 28 minus and then put the q squared plus q in parentheses.
Yes, you can. You can, and I'm going to show you why in a second, okay? All right, so I did this, and I was like, okay, now what? Now, I have a problem here because is my quadratic in standard form? Okay, so I have q to the second, I have q to the first here, and I have my constant at the end. So I'm going to rearrange it. Okay, and when I rearrange it, I have my minus q squared minus q plus 28, and it's over 7 times q plus 1 squared. I can abbreviate this. I just condensed it because this times this I know is q plus 1 squared.
That's it?
And, yeah, but if, and as Emily had said, she wanted to leave it this form, if you wanted to leave it as minus that q squared plus q minus 28, that minus would change everything inside. And the only reason why you might want to do that, Emily, is because generally when we're in standard form, we want it to be positive. We want our leading coefficient generally to be positive.
That I was asked. That's one of the one I was asking. I was asking if you could do 28 and then on top have a like 28 minus parentheses q squared plus q close.
But then you have to put it in standard form.
Good.
So
Yeah, you were just
Yeah, Stephen?
Earlier, someone asked why you couldn't make, was it m plus 3 times m plus 3, m plus 3 squared, and you said no. So why could you not do that? You can make q plus 1 squared.
There are going to be times, well, I can simplify this because it's very easy to see what, I can undo it if I need to, right?
Oh.
That's it. I can undo it. I know if I needed to. If when you end up at this point, like, could I cancel this or cancel it further, I can quickly go back to this. So generally, you don't. I mean, you wouldn't have been wrong, I suppose, if you had done it the other way.
Since the 1 plus 1 makes it easier?
Yeah, that's it. Okay. So far, so good. That was number 7. All right, do you want to see the rest of them? 7, 8. No, that was 8. 9. 9, 10. All right. here we go with number 9. Okay, can I factor that? And I ended up, this one was a pretty simple one. So what is the only thing that I need to remember to do? Multiply both sides by p. Okay, and I end up with both sides by p, and I ended up with 5p squared plus 7 over 5 times p plus 1. Yes.
Can I run to the bathroom?
Yes. Okay. Number 9.
What did you multiply those sides by? Are in each? Yeah.
Sorry, what's your question?
Oh, you multiplied by 2. I
You okay?
yeah, I'm right.
Where did the 3 and 7 go?
Pardon me?
Where did the 3 and 7 go?
7p was in the numerator. Oh, I dropped a p.
I don't,
Did I did. Hold on a second. What did I do here?
I don't think there was a
5p
P
plus
in the original.
number 9. There wasn't one. I added that one. There was no. There was none there. Okay. Okay. Number 10. We have again. We're factoring.
You need to do the dance.
Pardon me?
You need to do the dance.
Why?
It's-
Yes. Is this a difference of perfect squares?
Yeah.
No.
No.
Come on, Michael.
Okay. So I have x squared, and then this is just what? X times x plus 1, right? And so what do I need to multiply by?
X plus 1.
One side needs x plus 1, and what does the right side need?
X.
Another x. Okay? And so when I do that, oh, look at this. Did you end up with this mess? Did you end up with this? Yes?
Yeah.
Okay, so that would have been 3x plus 3 plus x squared plus 1x. Combine like terms. And I have x squared plus 4x plus 3. You need to think here. Can I simplify that numerator?
Of course.
Yeah.
What are the factors of that numerator?
3 and 1. Yeah,
So am I going to have an x plus 1 in the numerator?
yeah.
And a x
You can
plus
cancel.
3? There you go.
Oh.
Okay, so I know that my numerator, in this case, I can factor further. And then what's going to happen here? I'm going to cancel those guys out, and I'm just left with x plus 3 over x squared.
Oh.
Haley, didn't you go before?
That was me.
Okay. Okay.
Thomas and
Anybody else have any questions on that? Does that make sense? I mean, do you see how it's really about being comfortable with the idea of fractions? What I do to one side, I have to do to the other side when you're making a common denominator. And then it's all about factoring. If you can factor, these things should be pretty simple. Okay? Happy?
So that was the lesson for today?
No, that was yesterday. Sorry.
I think
All right, so we're going to try to do today's.
I don't